Today, I will solve two questions to help you and to make you able to see more questions related to the latest chapters that we are covering. So those questions will be about the production chapter and the cost chapter. The first one is on the production chapter, and here we have a firm and it has two different technologies. So the first technology is basically QA KL is equal to minimum of 2K and L, and the second one is QB KL is equal to minimum of 2K and 2L. Okay, so here the production functions. The production functions are fixed ratio ones, okay, that we covered in the class, and these are very related to the perfect complements. And in the question, it asks that show that both technologies have constant return to scale. So let's remember what we mean by constant return to scale. So if we have a production function of FKL, then it is, let's say it's given Q amount. Then if we increase the both inputs by some factor, let's say alpha K and alpha L, then our output level should be alpha Q. Okay. So in this question, basically, so I will be just focusing on the first one. Okay, the second one will be your homework. So if we have the first one here, so instead of Q, I will use F. FKL is equal to the minimum of 2K and L. Okay, so it means that, okay, whichever is the minimum, the output level will be equal to that one. Okay, so given K and L, I will compare 2K and L here, and whichever is minimum, then that will be the output level. So which means that, okay, if 2K is less than L, okay, then 2K is the minimum, then FKL is equal to 2K. If 2K is greater than L, then L is minimum, then it will be L. And if 2K is equal to L, it can be anything. Okay, so here by anything I mean it is L, and which is also equal to 2K. So what I want to do is basically I want to look at the following output level. I am multiplying both inputs with some constant. Oh, let me use a different color. Then my production will be alpha times 2K alpha times L. Okay. Then I will compare these two amounts, which means that if alpha 2K is less than alpha L, okay, so which implies that, okay, so we can cancel out the alphas here, 2K is less than L, my output level is alpha 2K. Okay, if alpha 2K is greater than alpha L, then alphas will cancel each other again. 2K is greater than L, then alpha K alpha L will be equal to alpha L. And finally, if alpha 2K is equal to alpha L, which implies that 2K is equal to L, then my output level is alpha L, and which is also equal to alpha 2k. Okay, so as you can see, these conditions are the exact same conditions here. Okay, and moreover, so I know that 2k is equal to the fkl. So when 2k is less than l, okay, so which is equal to, I can write it as alpha times fkl. Okay, it is also true for the other ones. Okay, so these are two are equivalent. This is alpha kl, and this is also alpha kl. Okay, so this completes the what we want to show. So then this is constant return to scale. Okay, so that is the first question that I would like to solve today. The second question will be from the costs. Let me share that question here. So this is my second question. So we have Evren here, and he wants a donut business, and the rent here is $5,500. Okay, and it's the bakery shop, and he must pay unionized donut bakers a monthly salary of $400. The wage is $400. He projects his monthly production function to be, okay, so FKL is equal to 5KL, and here Q is the tons of donuts. Okay, so in part A, it asks us to work in the short run. Okay, in the short run, K is fixed to 1. Okay, so then it asks that with the current level of capital, what is the marginal product of labor? And what I need to just do is basically I need to rewrite this production function with fixed K. Okay, it is 5KL. Since K capital is 1, K bar is 1, I will have 5L. And the marginal product of labor is df K bar L dl, which will be 5. Okay, this is the first one. The second part asks that he wishes to make 25 tons of donuts, and how many bakers are required to given at the current capital level. Okay, we are still in the short run. Okay, so we are in the short run. Then what we want here is, okay, so let's write the production function. Since K bar is fixed, I will just denote it by L, and my production function is 5L. Okay, so then I want to produce 25. Okay, then I will find that the total amount of labor that I need is 5. Okay, and how much will it cost to produce this? So we know that the cost is W times L plus R times K. W is 400 times 5 plus R is 500 times 1 is equal to 2,500. Okay. In part C, it asks us to derive the short-run cost functions. Okay. So here you need to be careful that the cost function needs to be written in terms of quantity. Okay. So this is the cost. We would like to write this in terms of quantity. Okay. So we know the exact value of k here, which will be 1. So what I just need to do is I need to write L in terms of quantity. Okay. And I can do it by using the production function. So if L is equal to quantity, which is equal to 5L, then for any quantity level Q, I need to have L equal to Q over 5. And if I want to write the cost function in terms of quantity, it will be WL plus RK. W is 400 times, instead of L, now I will use it in terms of Q over 5 plus R is 501, then I have 500 plus 80 Q. So this is the short run cost function. Okay. In part D, it asks us to derive the marginal cost curve from your answer part C and show the relation between the marginal cost and the marginal product of labor. Here, marginal cost is dCQ dQ, which will be 8. Okay. And the one last thing is, in the long run, everyone can adjust the level of capital, derive the long run cost function. So what we need to do here is the following. Okay, so we have isoquants here. Okay, so which are smooth shaped, and we also have the isoprocess. Okay, so we would like to find the isoquant. Okay, so let's say this is the isoquant where Q is 25, the level that we would like to achieve. And so what we want is basically we want the isocost which is tangent to that level. Okay, so this light blues are the isocosts, and here what we know is MRTS is equal to the slope of the isocost, and the slope of the isocost is basically minus W over R, which will be minus 400 over 500, which will be minus 4 over 5. MRTS is in fact minus marginal product of labor divided by marginal product of capital. The marginal product of labor is the cost function, sorry, the production function, the derivative of the production function with respect to labor, and the marginal product of capital is the derivative of the production function with respect to capital. Okay, so I have minus sign here. My production function was 5KL. Then the derivative with respect to L is 5K. The derivative with respect to L, K is 5L. Then I have minus K over L. Okay. Then this equation gives us minus k over L is equal to minus 4 over 5. And k is equal to 4 over 5 times L. Okay? And what is left is, I know that at this production level, okay, Q is equal to 25 is equal to the 5KL. Instead of K, I can write 4 over 5L. 25 is equal to 5 times 4 over 5 L times L. 5 will cancel each other, and I have L equal to 25 over 4, and L will be equal to 5 over 2. And K will be equal to, I will just plug in the value here, and the value will be 2. That's it. Okay.